Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy, and I am Jeetendra Dixit. Here is my profile. I did my BTech from IIT Kanpur and I have been mentoring IIT-JEE aspirants for last 11 years. So we were doing circles, and in this session also we'll continue circles. So in today's session we are going to discuss director circle and also the angle of intersection of two circles and orthogonal circles. But before we begin, let me tell you about the Unacademy subscription. So as you know, Unacademy is India's largest online learning platform. And if you are preparing for IIT-JEE, then you can have two types of subscriptions on Unacademy. One is Plus subscription and another is Iconic subscription. So in Plus subscription, you get unlimited access on the platform. You can watch live sessions of all the educators who are teaching for IIT-JEE. You can follow the educator of your choice. You have complete freedom. All the live tests and quizzes will also be accessible to you. And the courses which I'm talking about are well structured. That means everything is pre-planned. You can see the schedule of all the upcoming sessions in well advance. All right. These are the subscription charges. You can subscribe for 1 month, 3 months, 6 months, 12 and 24 months. 1 month's subscription charge is 7,000, and if you compare it with 12 and 24 months prices, then per month in 12 and 24 months comes out to be 3,200 and 2,300 around, approximately. And even and in that also you'll get 10% discounts. In all the subscriptions you'll get 10% discount, and right side list is given after 10% discount. All right, so final price is written on the right hand side, and you'll get this 10% discount using the educator's code. So you can use any educator's code. My code is JEET1. You can use this code also to get instant 10% discount. All right. Now the next is Iconic subscription. In this subscription you get all the benefits of Plus. Apart from apart from that, you get a personal coach who will guide you throughout your preparation for IIT-JEE and other top exams. Your test analysis will be done in a personalized manner. Personalized feedback will be given to you to improve your time management and exam approach. Your study planner will be your preparation will be customized. A study planner and bi-weekly reviews will be given highlighting your progress. Now, these are the subscription charges. You can subscribe for 6 months, 12 months, and 24 months. 6 month subscription charges are 38,000. 12-month subscription charges are 65,000, and 24-month subscription charges are 1 lakh. All right, and in these subscriptions you will get 10% discount also. So again, you can use the same code to get instant 10% discount. Now, this is Unacademy's learning app, which you can download from Play Store, and after downloading it, you can if you're a new learner, then you'll have to use the code. So again, you can use the same code to access the free content, and you'll get unlimited free content also. So free live classes you can attend, and top educators of Unacademy take these free live classes every day. Lots of topic are going on. You can attend, you can watch unlimited sessions, okay, without paying anything. All right, so this was about the application and the free content. This is the information about two batches which have started from 21st. One is a Spark batch for class 11th, JEE Main and Advanced 2023, and you can see the top educators who are taking this batch. And the second one is MCQ batch, so JEE Main and Advanced 2021. This is for JEE Main and Advanced 2021, and it has started on 21st of December. All right, and again you can see the educators who are going to teach, who are going to take this batch. Now let's begin the session. So the first point is, let me tell you about the director circle. So what is director circle of a circle? Of a circle. So what is director circle? So in circles, locus of point of intersection of tangents. I'll tell you the definition, because this director circle will get an ellipse and hyperbola also. So, and definition is same. Locus of point of intersection of mutually perpendicular, mutually perpendicular tangents, right? Locus of point of intersection of mutually perpendicular tangents is always a circle which is called the director circle. Locus of mutually perpendicular tangents of a circle, okay? I meant forget, of a circle. Of a circle is always another circle which is called director circle. Okay, so this is the definition. And this is also valid in ellipse also. Locus of point of intersection of mutually perpendicular tangents in ellipse is also a circle. In hyperbola is also a circle. Hyperbola there is one restriction, one condition, but in ellipse there is no condition. Okay, so I'll tell you, let me make the diagram. Say this is the circle, given circle. So I'll take the given circle as this given circle is x minus h the whole square plus y minus, okay, x minus, let's take x1. So x minus x1 the whole square plus y minus y1 the whole square is equal to r square. All right, so this is a circle whose center is x1 y1 and radius is r. Okay, radius is r. Now mutually perpendicular tangents, let's draw mutually perpendicular tangents, this and this. This is point P, this is 90 degree. Alright, so now let's see. If I draw this, join this also. O, A, P, B, alright? 90, 90. So OP is equal to, okay, yeah. So we need to find the locus of point P. Let's take this point H comma K, okay. Do we know OP? Yes, we know OP because this OB is R, okay. This angle between the tangents is 90 degree. This is 90 degree. This is 90 degree. So this angle will also be 90 degree, right? So this angle will be 45 degree, 45. And if it is 45 degree, then you can see OP cos 45 is equal to R, right? So you'll get OP is equal to root 2R. And we know OP. How to write OP? OP is nothing but under root of h minus x1 the whole square plus y minus y1 the whole square. K minus y1 the whole square. So you have got the relation in h and k, and this is the equation of locus of h and k. Okay, so k minus y1 the whole square is equal to r, and you'll get this h minus x1 the whole square plus k minus y1 the whole square is equal to r square. All right, and this is the locus of point P, equation of locus of point P. So x minus x1 the whole square plus y minus y1 the whole square is equal to r square. All right, so this is the answer. So I hope it is clear now. So director circle is a circle whose radius is basically root 2 times the radius of given circle and concentric with the given circle. Okay, so finally analyze it. So director circle of any circle is a circle whose center is which is concentric with the given circle and whose radius is root 2 times the radius of given circle. So this radius of this circle is root r. Okay, root 2r. This is, sorry, 2r square. Oh, sorry. And this mistake, let me correct it. So this was root 2r, then this is 2r square. All right, so it's 2r square. So radius is root 2r. Okay, radius of director circle is root 2r. So I hope now you have got this point. Now find the equation of director circle of x square plus y square minus 8x plus 4y, okay, 8x plus 4y minus 4 is equal to 0. Okay, so try this sum. Try to find the equation of director circle of the circle, and then we'll proceed. So I'll repeat equation of directors. Director circle is a circle which is concentric with the given circle and whose radius is root 2 times the radius of given circle. All right. All right. So now let's see what is the center of the circle. Center of the circle is 4 comma minus 2, and if you write the radius of the circle, so radius is under root of 4 square plus minus 2 square plus 4. All right, this is the radius. So radius is 4 plus 4, 8, 8 plus 16 is under root of 24. All right. So the radius is 2 root 6, right? 2 root 6. Okay. So now director circle, equation of director circle. Equation of director circle is same center, so x minus 4 the whole square plus y plus 2 the whole square is equal to 2 root 2 times of radius. This is 2 root 6, okay, or root 24 you can say, the whole square. This is the answer, okay, in this form, or you can expand it. So it is x square plus y square minus 8x plus 4y plus 16 plus 4 is equal to this is root 48, so it will be 48. Okay, now I can simplify and club it. So it is x square plus y square minus 8x plus 4y and plus it is 20. So if you bring this term to left hand side, is minus 28 is equal to 0. All right, so this is the equation of director circle. So now I hope you got it, how to find the equation of director circle. Now this, I'm giving you one more question related to director circle. It's not director circle because, but it's based on the method which we use to find the equation of director circle. Find the locus of point of intersection of tangents to the circle x square plus y square minus 2x minus 2y. Okay, let's take x square plus y square because we just need to understand the method. So x square plus y, standard circle I'm giving x square plus y square is equal to 9, whose angle of intersection Angle of intersection is 60 degree. Okay, so in case of director circle it was 90 degree, now it is 60 degree. Okay, so you need to do it accordingly. Find the locus, find the equation of locus, find the equation of locus. So I'll make the diagram for you. This is the point whose locus you need to find, PH comma K. This is say A, this is B. This angle is given 60 degree, alright, you need to use it. I am also constructing OP. You need to use this OP also. Find the locus. Okay, now let's see, this angle is 30 degree, half of the angle. This is 90 degree. So you can see this is our radius. Radius is 3 actually. So 3. Again you can see OP sine 30. OP sine 30. In triangle OA, in triangle OAP you can see this is angle 30 degree, this angle is 30 degree. Okay, so I'm using this triangle, right? This is a right angle triangle. So OP sine 30 vertical projection, okay, of hypotenuse. So OP sine 30 is equal to how much? Radius R, which is 3. So here say I'll get OP. So OP is equal to 3 into sine 30 is 1 by 2. So it is 3 into 2, which is 6. Okay, OP is equal to 6. Now see, OP is 6, O is given, we need to find, so we can write the OP. OP is again H minus 0 square plus K minus, it is again a circle, can you see that? The only thing is length has changed, radius of the circle is different now, it is a circle only. So if you square it, you'll get another circle, H square plus K square is equal to 6, 36. So in case of, now you can replace H and K by X and Y, so it is X square plus Y square is equal to 36, alright? So you know, in case of circles, whenever angle between the tangents is given constant, angle of intersection of two tangents is given constant, then locus of the point of intersection will always be a circle, and it will be a concentric circle with the given circle, alright? Radius will be different. So now I hope you've got this point. Yeah, now angle of intersection. Angle of intersection. Angle of intersection of two circles. Now, one circle is, I want to solve this question in terms of distances, okay? So suppose two circles are given. Let me make the diagram first. And these two circles are intersecting. These two circles are all right. This is A point, this is B point, all right. So these two circles are intersecting at A and B. Let's complete this diagram. Say centers are C1, C2, so I'm going to derive the formula in terms of C1, C2 and radii. So see this, first of all, let's make the tangent at point A. So we make a tangent at point, okay. This is tangent at point A, which is not passing through center. This is tangent to another circle at point A, okay. So these are tangents. So angle between the curve is nothing but angle between their tangents, right? I hope you know that. Angle between the curves is nothing but angle of intersection means angle between their tangents at their point of intersection. So basically we need to find this angle, okay? This angle is theta, say. This angle is theta. This is C1 and this is C2, all right? If you join A to C1, this diagram will be like, wait a minute. Let me change the color of this circle. Let us make it white to yellow. Then we can use white color. So now you can see this is the radius of first circle. If I join it to A, and this is the radius of second circle. Okay, this is R1 and this is R2. All right. Say this point is P and this point is Q. So angle PAQ is theta. All right. We need to find this angle theta. This angle is theta. Okay. Now if I make this diagram separately, then can you tell me what is this angle, by the way? This diagram is like this. This is C1, this is C2, this is P, okay, and this is Q. This is Q. Do you know what is the angle between radius and tangent? Because this is radius and this is tangent, okay? This is tangent, PQ. So this angle is 90 degree, correct? This angle is 90 degree. If this angle is 90 degree and total angle is theta, then what is this angle? This angle is theta minus 90, right? Similarly, this is radius R2, radius of this circle. Can you see this radius R2, and this is its tangent. AP is tangent, so radius angle between AP and radius R2 is also 90 degree. So this angle is also 90 degree, right? And this total angle is theta. So what is this remaining angle? This remaining angle is also again theta minus 90, right? So if I talk about the angle C1, angle C1P C2, then that angle is nothing but total angle, which is theta, minus 2 times of theta minus 90, right? So that is going to be 180 minus theta, 180 minus theta. Okay, that is the answer, 180 minus theta. I hope you're getting this point. Now, why am I using this angle? Let me tell you. Because in this triangle, in triangle A, C1, C2, you know all three sides, okay? We know all three sides of this triangle, A, C1, C2. AC1 is radius R1, AC2 is radius R2, and this is C1, C2, okay, distance between the centers, because circles will be given, so we can use the distance between centers. And this angle we can write in terms of theta, it is 180, and pi minus theta, alright. So using cosine formula in any triangle, if you know all three sides, we can find the angle using cosine formula. So if you apply that formula, then cos of pi minus theta is nothing but R1 square plus R2 square minus C1 C2 the whole square divided by 2R1 R2, okay. Cos pi minus theta is minus cos theta, so from this you'll get cos theta is equal to, minus you can send to right hand side, C1 C2 the whole square minus R1 square minus R2 square divided by 2R1 R2, okay. So this is the formula which you can use to find the angle of intersection of any two circles, okay. Directly you can use this formula. Alright, so I hope now this formula is clear to you. This was the beautiful derivation of this particular formula. Now you can memorize it. And also let me tell you, circles are called orthogonal to each other if they intersect at 90 degrees. So if theta is equal to 90 degrees, that means cos theta is equal to 0. And cos theta is 0, that means C1 C2 the whole square is equal to R1 square plus R2 square, alright. So this is the condition for two circles to be orthogonal, okay. Circles are called orthogonal circles. Circles are called orthogonal circles. And now let's see. So this condition of orthogonality of two circles, condition of two circles. So if two circles S1 is equal to 0 and S2 is equal to 0 intersect each other at 90 degree, then we know that C1 C2 the whole square is equal to R1 square plus R2 square, okay. You can remember the condition in this particular form. This is one form. But if circles are given, say S1 is a circle, x square plus y square plus 2g1x plus 2f1y plus c1 is equal to 0. And S2 is another circle which is x square plus y square plus 2g2x plus 2f2y plus C2 is equal to 0, right? Then C1, C2, apply this formula again. Let's rewrite it. So C1, C2 is, if I apply this, then C1, C2 is nothing but G1 minus G2 the whole square plus F1 minus F2 the whole square. This C1, C2 square is equal to R1 square is nothing but G1 square plus F1 square minus C1, and R2 square is G2 square plus F2 square minus C2, alright. So if you open it, you can see this left hand side, it is G1 square plus G2 square minus 2G1 G2 plus this F1 square plus F2 square minus 2F1 F2 is equal to G1 square plus G2 square plus F1 square plus F2 square minus C1 minus C2, alright. So G square, F square, G1 square, G2 square, F1 square, F2 square, F1 square, F2 square, alright. And then you can cancel minus sign. So it is 2G1, G2 plus 2F1, F2 is equal to C1 plus C2, okay. So in case general equations of circles are given, then you can use this formula, the same formula, which is formula number 1, in this form also, okay. They both are same actually. Formula number 1 and formula number 2. So if you can see, if circles are given in x minus x1 square plus y minus y1 square is equal to r1 square, and x minus x2 square plus y minus y1 square y2 square is equal to r2 square. Then you can use formula number 1, and if circles are given in this expanded form, general form, then you can use this second formula, 2g1 g2 plus 2f1 f2 is equal to c1 plus c2. All right, so I hope you got this point. Okay, I'll give you one question. Find lambda if x square plus y square plus 2 lambda x minus 6y plus 1 is equal to 0, and x square plus y square minus 4x minus 2y plus 3 is equal to 0 cut each other orthogonally. All right, so try this one. All right, so I hope now you have got the answer. Now let's apply this. All right, so in first circle you can write G1. So G1 is equal to lambda, F1 is equal to minus 3, and C1 is equal to 1. Then similarly you can write G2. G2 is equal to minus 2, and F2 is equal to minus 1, and C2 is equal to 3. All right, then you can apply 2G1 G2. So 2 into G1 into G2 plus 2 into F1 minus 3 into F2 is minus 1 is equal to C1 plus C2, 1 plus 3. All right, then you can get minus 4 lambda, and this is plus 6 is equal to 4, and you'll get minus 4 lambda is equal to minus 2, and you get lambda is equal to 1 by 2. Okay, so that is the answer. Lambda is equal to 1 by 2. Alright, so I hope now you have got it, how to apply this formula and how to find the values of the parameter. Alright. Now, if I ask you, find the angle of intersection of circles x square plus y square is equal to 16, and x minus 2 the whole square plus y minus 3 the whole square is equal to 9. All right, now let's see, find it. It's direct straightforward question based on formula which we have just derived, so just it's the application of that. Write it. All right. So if I simplify it, it is going to be, see, what was the formula by the way? Cos theta is equal to C1 C2 the whole square minus R1 square minus R2 square divided by 2 R1 R2. All right, so let's apply that. C1 C2 is what? C1 C2 is 2 minus 0 the whole square. Okay, so 2 square plus 3 square, this is C1 C2 square minus R1 square is what? R1 square is 16 minus R2 square is 9 divided by 2 times of R1 is 4 into R3 is 3. Okay, this, so it is 9, 9, 9 will get cancelled, 4 minus 16 is minus 12 divided by 2 into 4 into 3, so it is minus 1 by 2. All right, then you can see cos theta is equal to minus 1 by 2. Cos theta is equal to plus 1 by 2 when theta is equal to 60 degree. So cos theta is equal to minus 1 by 2 when theta is equal to 120 degree. Okay, so this is obtuse angle, and you can also write acute angle, which will be 60 degree. So angle of intersection of these two circles is 120 degree, or you can say 60 degree also. All right, so this is the answer. Obtuse angle is 120 and acute angle is 60 degree, because this angle is nothing but the angle between their tangents, and angle between two lines is theta or 180 minus theta. Okay, so using that you can say 120 degree or 60 degree. All right, so I hope now it is clear. Now let's do some other points. So chord of contact, okay, equation of chord of contact. So if a circle is given, so what is chord of contact by the way? See, this is a circle, S is equal to 0. S is equal to 0. A point is given P x1 comma y1. Okay, point P x1 comma y1 is given. From P, tangents are drawn. Okay, tangents are drawn which touch the circle at A and B. All right, and you can join A, B. Okay, so PA and PB are tangents, and AB is called their chord of contact. So chord joining the points of contact of tangents drawn from point P is called chord of contact of the circle S with respect to point P. Chord of contact of, or you can say chord of contact of tangents drawn from point P. Okay, chord of contact of tangents drawn from P to S is equal to 0. All right, yeah, this one. So what is the equation? Equation of chord of contact is T is equal to 0. All right, T is equal to 0 we were using for tangent also, but that time this point P was on the circle. Okay, this P was on the circle, now this P is outside the circle, and from that point we have drawn the tangents, and now this T is equal to 0 is representing this line. Okay, you can understand like this. If I explain you. Like if P is this, P is here, then this is T is equal to 0. If you can bring P closer, then this line will become T is equal to 0. If you bring T here, P point on the circle, then this line will come here, okay? It's like this. It's easy to understand it, okay? What is happening. Okay. So if P is outside, then T is equal to 0 represents chord of contact. If P comes closer to this line also comes close to this point P, and then P, when P comes on the circle, this line coincides with that and becomes tangent. And when P goes inside, this line will go outside actually. I guess I'll do that later. So this T is equal to 0 is, you know how to write T, okay? So we'll use it directly. Now let's do another problem, another point actually. Chord, one more chord we are writing. Equation of chord of circle S is equal to 0. In fact, this chord and chord of contact, this chord of contact I have not written only for circle. It is true for any curve. T is equal to 0. T is equal to 0 when P lies on the curve, whether it is circle, parabola, ellipse or hyperbola, it is always a circle, it is always a tangent, okay? Similarly, if P is outside the curve and tangents are drawn from P, then T is equal to 0 represents the chord of contact of those tangents, all right? And if P, so that means T is equal to 0 is valid for all the curves, parabola, ellipse and hyperbola. So it will remain same, this formula will remain same. And similarly, the chord equation of chord of S is equal to 0 bisected at P, x1, y1, okay? Now I'm not saying circle because this is also generalized, okay? Generalized. So you can use it for circle also. So this is a curve, S is equal to 0, 2-degree curve, okay? Parabola, ellipse and hyperbola. And we need to write the equation of a chord whose midpoint is given, and midpoint is given x1, comma y1, okay? So let's see how to write it. So equation of chord is equation of AB. Let's say AB is the chord. So equation of AB is nothing but T is equal to S1, okay? T is equal to S1. So let's say for circle, S is equal to 0, S is equal to 0 is circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0. Then we know how to write T. T is x1. We are writing T and S1 with respect to the midpoint, So x1 plus y1 plus g x plus x1 plus f y plus y1 plus c. This is T is equal to. Now put x1, y1 on the equations. It's a constant. x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. All right. This is the equation of circle. Sorry, equation of line. Now this is very important actually. This midpoint form of chord is very important because they ask the locus of midpoint of any curve if chord does something. So I'll give you one question based on this. Find the locus of midpoint of a variable chord of x square plus y square is equal to 4, okay, which touches x square plus y square is equal to 1. Okay, I'll give you another, which actually not touches, which passes through say 3, 4. This one is a very, very easy problem, okay, but very important as well. All right. Okay. So find the locus of midpoint. So let's see how to start this question. This chord could do anything, like it is passing through a fixed point is the easiest problem. It could touch some other curve like parabola. It could cut intercept of fixed length between the coordinate axis. It could touch some ellipse, hyperbola, or another circle. Okay, so accordingly you need to apply the condition to find the locus. How do you start? How to do this question is see how to do. First of all, you need to draw this line, one of the chord, and take its midpoint as h comma k, because you need to find the midpoint, locus of midpoint. Okay. Now the first point is this. After doing it, you can write the equation of AB. So equation of chord AB. This is A, this is B. You can write using T is equal to S1. So with respect to this, it is XH plus YK minus 4 is equal to H square plus K square minus 4. So you can see it is HX plus KY is equal to H square plus K square. All right. This is relation number 1. Okay. Now what is this chord doing? Now this chord is passing through a fixed point. That means you need to find the locus of all these chords. All these chords. Can you see this? The midpoint. So it is going to be like this, curve something like this. Okay. Now, so this curve is passing through 3 comma 4. So just do it. Put 3 comma 4 in this equation. So it is going to be 3h plus 4k is equal to h square plus k square, and you can see it's a circle with center. Okay, now you can replace hk by x and y. So it is x square plus y square minus 3x minus 4y is equal to 0. So its center is minus 3 by 2 plus 3 by 2 and plus 4 by 2. That is the center. Alright, so I hope you got this question. This is a very, very good question. Whenever he asks for the locus of midpoint of a variable chord, then always assume the coordinates of the midpoint and then write the equation of chord using t is equal to s1 and then apply the condition whatever that chord does. If that chord passes through a fixed point, put the coordinates of that point in the equation like we did here. If that chord touches some curve, then apply the condition of tangency. Okay, like we did condition of tangency for a standard circle x square plus y square is equal to a square. If line y is equal to mx plus c touches this circle, then c square is equal to a square 1 plus m square. Okay, so you can use that, something like that. Now the last point is combined equation of tangents. This is also same for all the curves. Combined equation of tangents from p x1 y1 to s is equal to 0. Okay, so you need to remember this formula also. So I'm telling you 2-3 formulae which are valid for all the curves, all the conics, all the 2-degree curves. So combined equations, you see we have already done tangents. Of course, P is an external point in this case. So two tangents can be drawn from point P, and we need to find their combined equation, PA and PB. Okay, PA and PB. Can you see that? P is outside. P is a point outside the curve. So we have already done the equation of tangents in separated form. Yes, of course you can do that. You can find the equation of tangents in separated form PA and PB individually, and then you can multiply them to find the combined equation. But we have a direct formula to find that combined form. So no need to no need to do that process which we have done earlier. Direct formula is so combined equation of PA and PB is equal to S1 is equal to T square. Okay, S1 and T we need to write with respect to point P. S1 and T, write S1 and T with respect to point P. Okay, X1, Y1. So I hope you're getting it. Now I'll tell you how to use it. So find the combined equation of tangents from 3 comma 4 to x square plus y square is equal to 4. All right, yeah. So now we know that formula. This is a circle where whatever circle is this, no, it doesn't matter where is its center. This P should be outside. So yes, P is outside. Then only we can find. Otherwise, tangents will not exist. So combined equation of P and PV is going to be S1 is equal to T square. What is S? This curve equation of curve is S. Okay, this is S. So this is x square plus y square minus 4. This is S. If you write S1, that is nothing but just put the point in the equation, it should always be positive. That means it's outside the circle. So it is 9 plus 16 minus 4. So you can see, yes, it is a positive quantity, it's 21. Alright, so I hope it is clear. Now the third one is T. T is what? T is XH. So XH is 3 actually. We are writing it with respect to 3 and 4. So x into 3 plus y into 4 minus 4. Okay, this is T. Now apply that. SS1 is equal to T square. So you put the values x square plus y square minus 4 into 21 is equal to T square. So T is 3x plus 4y minus 4 the whole square. All right. If you open it, it is 9x square. So 21x square plus 21y square minus 84 is equal to 9x square plus 16y square plus 16 minus 24x minus 32y okay. So you can see it is 9. If I finally write it in a simplified form, yeah, it's a 2-degree general equation because pair of straight lines is represented by 2-degree general equation. So it is 12 x square plus 12, sorry, 16, 21 minus 16 is 5. This is 5y square. 5y square minus plus minus this term minus 24xy minus plus 24x and plus 32y. Okay, this done, and then that's 84 minus 16 is 100, right? Yeah, so minus 100 is equal to 0. That is the answer. Okay, this is the equation of pair of straight lines. So whenever you need to find the combined equation, combined, not separated, okay, combined equation, use this formula. But when you need tangents PA and PB separately, then use the process which we have done earlier, okay? Use that process. Assume the slope, write the equation of line passing through and apply the condition of tangency. Or write the equation in slope form and then put the coordinates of point P in that equation, all right? So you can use any one of the method. All right, so today we are going to finish it here. Thank you very much for joining this session, for watching it. Like and subscribe the channel. And as I told you, you can use Jeet1 code to access the content. If you're a new learner, then you can use this code to access unlimited content, free content on the platform. And also you can you can get instant 10% discount in any of the subscriptions you are planning to buy. All right, so thank you very much once again. See you.